you.
Hello guys to my channel. My name is Aditya.
My name is Akanksha. My name is Prachiti.
Has it ever happened that one fine morning you woke up and out of all the problems going on in your life, you felt the need to make a car follow a line? No, right? But I am different. The same way my crush ignores me, I ignored all my problems and got right to work. I started researching and came to know that these type of bots already exist. So I did some more research and found out that there is one common component that all of these bots use. It is called a microcontroller. I started searching for a microcontroller and realized that I didn't have one. Then I got an idea. I know that this video is boring, but programming is boringer. Boringer? I don't know if this word exists. Anyways, who wants to program a microcontroller when we can make a line follower bot without programming? I called my team and told them about the project. They were very impressed. So, under the guidance of Professor Najib Ghatte and Professor Sneha Weakey from the Sardar Patel Institute of Technology, we started working.
After intense hours of working, working, we finally got our results.
Explain the simulation working of our line follower robot. The objective of this project is to make the robot automatically follow a black line on a white surface. So the circuit mainly consists of a left sensor pair, a right sensor pair, a comparator section, and a motor driver section. Now I will explain the working of the left pair and the main motor control circuit. Similarly, the right pair works in the same manner. So in the left pair, it consists of an IR LED, a sensor model, a LM358 comparator, a potentiometer and resistors. The IR LED, this LED3, continuously emits infrared rays towards the surface. If the surface is white, more IR light is reflected back, and if the surface is black, the IR light is absorbed and very little light returns. Now for the sensor operation, the photodetector is represented using a sensor which is connected near the LM358 comparator input. The sensor simulates the change in received IR intensity. More reflected IR produces one voltage condition, less reflected IR produces another voltage condition. Thus, the sensor output changes according to the surface color. Now the working of the comparator, the LM358 op-amp is used as the comparator and it compares the sensor voltage with the reference voltage set by the potentiometer. The potentiometer is used to adjust sensitivity. If the sensor voltage crosses the reference level, comparator output becomes high, otherwise comparator output becomes low. Thus, the comparator converts analog sensor signals into digital logic signals. Now, the main motor driver circuit, the comparator output is given to the main circuit through diode D1. The diode prevents reverse current flow and isolates signals. The signal is then applied to transistor Q3, which is a 2N222 NPN transistor, and the transistor acts as a switch and a current amplifier. Since the comparator cannot directly drive the motor, the transistor provides sufficient current for motor operation. Now for the motor on condition is given by the comparator when the comparator output is high. So the transistor Q3 turns on, current flows through the motor and the left motor rotates. This helps move the robot. And motor off condition is given when the comparator output becomes low, the transistor turns off and the motor stops. This changes the robot direction for line correction. There is also a flyback diode, the 194007 diode, which is connected across the motor ends to act as a flyback protection diode. So when the motor suddenly switches off, the reverse voltage called back EMF is generated. The diode protects the transistor from this reverse voltage. Now the robot direction control. If the left sensor detects the black line, the reflected IR decreases, sensor output changes, comparator output also changes, and the left motor operation changes, and the robot corrects its direction. Similarly, the right pair works in the same manner for controlling the right motor. Thus, this simulation successfully demonstrates the working of a line follower robot.
Now let's get to the actual hardware implementation of this project. The project consists of three blocks. The power supply block, which consists of a lithium-ion battery, a buck converter, and a switch. Then a comparator block, which consists of LM358 and the motor drivers. Starting with the power supply block, there are three components: a battery pack, a buck converter, and a switch. The battery pack consists of two lithium-ion batteries, each of 3.7 volts, together making it 7.4 volts, which is connected to the buck converter via a switch. The buck converter basically steps down the voltage to 3.4 volts, which is used to power the whole circuit. Coming on to the comparator block. The comparator block uses LM358 IC, which is a dual op-amp IC. The input of the op-amp is given by the two sensor blocks. The sensor detects white and black and gives output accordingly. The output is given to the inverting terminals of the op-amps. It is constantly compared with the reference voltage, that is 1.5 volts, given through the supply. The output of the IC drives the motor drivers. The motor driver circuit consists of two transistors, that is N double two double two, which are used to drive our output, that is the motors. The whole circuit works on the supply of 3.4 volts. The output of the IC is around 1.2 volts, which in turn drives the transistor's base, and the transistor pulls down the motor and drives it.